Good afternoon, class. Today we're going to look at rational and radically. Oh, wait a minute. Let me do this. There. So y'all can see what I'm doing. There, now y'all can see everything. So let me dim this a little bit. Okay. Today we're looking at rational and radical equations. Oh, remember we have a lot of videos already embedded in here from previous semesters. Seems like we know this is one of the sections that students have problems with, so we have a lot of videos. And remember, you gotta, even if you're not going to watch them, this is the one that really gets messy, okay? And so, still got to click all this stuff in order to get the problems. Wow. Now here's the Pearson lecture videos. Okay, so there we are. I'm going to switch over to my tablet. We're looking at rational and radical equations. A rational number is just a fancy way of saying a fraction. A rational number is an integer over an integer, in other words, a fraction. So a rational equation is just a fancy way of saying an equation containing fractions. A rational equation is an equation that contains fractions. Move all these codes. Now, fractions aren't always defined. If you think about fractions involving, let's just think of rational numbers, okay? Something like 8 divided by 2. 8 divided by 2. Back in elementary school, what did you learn first? Multiplication or division? Multiplication. And once you got to division, they said 8 divided by 2 is equal to 4 because 4 times 2 is equal to 8. That's the definition of division. The quotient times that divisor gives you the dividend. Or in other words, the quotient times the denominator gives you the numerator. And that's just the standard definition of division. Suppose I have one I want to look at. 8 divided by 0. What number times 0 will give us 8? What happens when we try to divide by 0? There's nothing that you can do. No matter what you put here, if you multiply it by 0, what are you going to get? 0, not 8. So we say division by 0 is undefined. And someone in yesterday's class mentioned 0 divided by 0 equals 1. No, it doesn't. Realize division quotient is unique. 8 divided by 2 is 4. And it can't be anything else. There's not any other numbers. It's just 4. So, what number times 0 will give you 0? Well, really anything, right? Someone yesterday said it was 1. No. It could be 50 million, because when you multiply it by 0, you still get 0. And so, even if it's 0 over 0, that fraction is still undefined. So, let's make a note. Okay, a number divided by 0. A number divided by 0. That says no, you can't do it. N-O, no. That is undefined. And suppose we have 0 divided by some non-zero number, say k. Not 0 divided by 0, but 0 divided by anything else. That says okay. It's okay for the 0 to be on top. That's equal to 0. But the important thing is a fraction is undefined when the denominator is 0. So I'm going to write that out. A fraction is undefined when the denominator is equal to 0. The first couple of problems in this assignment, they're not asking you to solve the equation. They're just asking you what numbers could not possibly be equations. In other words, what numbers make the fractions that appear undefined. So let's not make these first couple of problems more difficult than they are. Trust me, there'll be plenty of hard problems in this assignment. So the ones that are pretty painless, let's just be glad that they're easy. Okay, so there we are. They give us the equation. This is number 1 from, let's see, let me write it down. This is number 1. And this, by the way, what is this? Homework 6? Okay, 7 over 3x plus 4. Then we have a minus 1 over x minus 1 is equal to 0. What values of the variable cannot possibly be solutions? Don't solve the equation. They just want to know what numbers could not possibly be solutions. So, looking at, let me move this up, there. I see 2 separate denominators. Neither denominator can be 0. So 3x plus 4 cannot equal 0. And x minus 1 cannot equal 0. We'll just solve this thing as if it were an equation. Even though it's a not equal to, you use the same procedure. What would I do to get rid of that? I want to get x by itself. Well, subtract 4, I agree. So we have 3x cannot equal negative 4. And then divide by 3, I agree. So here's one number. If you solve for the equation, you went through the process, and you wound up with negative 4 over 3 as a solution, you'd have to mark it out. Negative 4 over 3 cannot possibly be a solution. So here's one answer. Oh, this one's easy. X cannot possibly equal 1. I agree. So if we went through and solved this equation, and we wound up with x equals 1, we'd have to mark it out. If we went through and solved it and got negative 4/3, we'd have to mark that number out. So we come over here, and we have negative 4/3. Do not put, even though they may accept that comma in the denominator, very soon now they'll stop accepting it. So don't even make that a habit. Once you type the fraction, before you put that comma, use a right arrow, or you can click with your mouse. But notice, it's no longer flashing in the denominator. I put my comma and 1, check answer. Before we go on, don't bother writing what I'm about to do down, but it really doesn't matter the numerator. The numerator can be anything. It's when the denominator's 1. It seems like my math lab just likes, for these problems like this, where you're trying to figure out where what numbers could it be solutions, they just put numbers up there. That could have been a 7x minus 5 there. That could have been a 11x minus 4 up there. the numerator has no impact, even if that had been a messy numerator. To determine when a fraction is undefined, all you look at are the denominators. So the numerators could be anything. Okay, number 2. Let's see, number 2. Let's see. Decide what values the variable cannot possibly be solutions for the equation. Okay, this is number 2. Let me write it down. 1 over x plus 3. Then we have plus the fraction 1 over x plus 1 equals 1 over x squared minus 2x minus 3. Once again, they're not asking us to solve this equation. They're just asking us to figure out what numbers cannot possibly be solutions. Oh, thank you. Thank you. Uh-oh. I can't believe it. Yesterday I did the same thing, except I changed the plus 1 to a minus 1 here, okay? Or what? I changed the signs. It was different numbers, but I changed the signs. I did the same thing. Thank you for pointing that out. Okay. Thank you. That is a minus. Y'all see? Oh, wait. Notice I wrote an x plus 3. It should be a minus 3. And when you stop me doing that, please call out, okay? So, oh goodness. That is an x minus 3. Can y'all read? You know what I'm going to do? I'm going to just mark it all out and write it there. Okay? Well, that looks terrible. I'm going to rewrite the whole problem. 1 over x minus 3. Wait, I better make sure I'm writing the problem down correctly. Oh, this is being recorded. I look like an idiot. Oh, that's okay. And make sure. Yeah. It's just weird that I made the same type of mistake on the same problem yesterday. Okay, is that right? X minus 3. X plus 1. Yes. Okay. Well, when is a fraction undefined? It's undefined when the denominator is 0, so we cannot allow x minus 3 to be 0. We can't allow x plus 1 to be 0. And, we can't allow x squared minus 2x minus 3 to be 0. Well, the first two are painful enough. Moving this, getting the x by itself, we get that x cannot equal. Moving the negative 3 over, that gives us a 3, okay. Okay, getting this x by itself, moving that 1 over, we get that x cannot equal. Negative 1, good. Uh-oh. This last one here, it's quadratic. Fortunately, it's in standard form. Notice it's already set equal to 0, or not equal to 0. It's a simple trinomial. I think we can factor it. Okay, and x squared, there's only one possibility. 1x times 1x, so that's not too bad. 1x times 1x. Hey, I did ask you, what do we know about the signs? The last sign's a minus? Okay, that's right. It's going to be a plus and a minus, and you wait. So, you know something, I squashed it in. I normally write the little plus minus right up there. I'm just going to write it right here, because there's only one possibility for 3. What is it? 1 and 3, play it out in your head. You want to get a negative 2x. Where should I put the 3? After the plus or after the minus? Now I'll put the 3 there. and the plus there, and wait a minute. These two factors, they look mighty familiar to me. Didn't we just see x plus 1 and x minus 3? Yeah, where were they? We've already taken into account those numbers. They factored using x plus 1 and x minus 3, so we already know that x can't equal negative 1. We already know that x can't equal positive 3. We already found that here. So there are really only two numbers that cannot possibly be solutions, 3 and negative 1. Any questions? That trinomial, their factors using the other two denominators. So the only numbers x could it possibly be is 3 and negative 1. But at this point, we're going to have to start solving these things. Okay, the first two, they didn't tell you to solve them. Now we're going to start solving. What we're going to do is what we did with that last example that we did, I think it was number 14, or it was one that had fractions. It was one with fractions in the last homework assignment. And instead of using the quadratic formula with those fractions, we said multiply through by whatever it takes to cancel out every denominator. This one isn't as bad as you might think. So let me write the problem down. This is number 3. Oh, notice, don't write it down yet. Notice something, that the way I'm about to write it down. Let me write it down, then you write it down. I'm going to spread this stuff out. Remember, we're going to be multiplying through by stuff in order to cancel out denominators. So I'm going to want to leave enough room to show where to write in the stuff that I'm going to be multiplying through by. So hold on. There. Here. Notice how I left that room there. I left room in front of each of the fractions, and I have room over here on the right-hand side also. We'll do this example, and then I'll write out a general procedure that I use. I look at the two denominators that are appearing. 2, that's just a number. You can't factor that. That just stays 2. X minus 2. Can that be factored? Think about when we were factoring. When we were factoring stuff, what had to appear? Maybe an x squared? There's no x squared there. X minus 2 can't be factored. So, if you have two distinct denominators and they cannot be factored, the least common denominator is just the product of those denominators, and that's what you're going to multiply by. I'm going to make a note, and I'm going to use the I'll write it out. Least common denominator is just the product of the two denominators, 2 times x minus 2. We know from properties of equalities, you can multiply both sides of an equation by anything you want to, as long as it's not 0, and you don't change the equality. So what we're going to multiply through by is that LCD, 2 times x minus 2. We're going to have to distribute. That means every term, the first fraction, the second fraction, and then when we move over here, that thing there, just the x, also has to be multiplied by 2 times x minus 2. So this might get a little messy. We're going to multiply the first fraction by 2 times x minus 2. And there's no denominators, but it might look better if we put it over 1. And then the second one, we multiply by 2 times x minus 2. This over here, this term, there are 3 terms. Each separate fraction is a term. And when you move to the other side of the equal sign, you have a term. So you're going to multiply that by 2 times x minus 2. Remember why you're multiplying like this. You're trying to cancel out every denominator. So, I want to cancel that 2 right there. I can cancel the 2 in the denominator with that 2 right there. So what have I got left? I have an x minus 2, and that's going to be multiplied by, what else is left? The 2x plus 5. Minus, this minus right here is that minus there. Now, we need to cancel the x minus 2. That's where this other x minus 2 comes in. Cancel the x minus 2. Oh, I think we can do this in our head. We have a 2 times what? 2 times 3x. 2 times 3x gives me 6x equals. Before we go on, any questions there on my logic? We're multiplying through by whatever it takes to cancel the denominators. But the downside is, even if a term doesn't have a fraction, you still have to multiply through by that. X times 2, I know that's 2x. So we have 2x times that x minus 2. Any questions here? I say that the problems here is the messiest we've seen because we're going to have to do pretty much use everything we've seen so far to get through, to solve these equations. Well, look at this. We have a binomial times a binomial, 2 terms times 2 terms. What are we going to have to do there to get rid of those parentheses? Starts with an F, 4-letter word. FOIL, I agree. So, let's see. First, x times 2x gives me 2x squared, I agree. Outer, x times positive 5. Okay. Oh, I don't like that color. It's not showing very good. Inner, negative 2 times 2x and negative 4x, I agree. Last, negative 10. And we still have that minus 6x I'm going to bring down. Equals, what have we got on the right? Okay, so you're distributing 2x squared, keep going, minus 4x. I agree. Well, when we look at this, it's quadratic. I see x squares, but wait a minute. Is this really going to be quadratic? We have x squares on the right and x squares on the left. Why don't we try to get all the x squares combined on the same side? Let's see. There's got to be a red pen here that's working. Let's see. No. I don't know what happened to our red pens. Okay. Well, this is a positive 2x squared. What could I do to both sides to get that x squared term over on the left? Minus, look at what's going to happen. It's going to cancel out. Right. So we are getting a break here. This is actually very good. 2x squared minus 2x squared, that's gone. So we're just going to have a linear equation. We still have quite a few terms. Let's combine them. 5x minus 4x gives me 1x minus 6x gives me what? Okay, I agree. 1x minus 6x gives us a negative 5x. And we still have that minus 10 right here. You see where I'm getting the minus 10? I'm just moving it down. What have we got on the right-hand side? Okay. This is a linear equation. We need to get all the x terms on the same side and then divide by the coefficient. I can't hear you. Yeah, we could do that, but then we'd have to move this negative 10 over to the right. It might be quicker, okay, if we move the 5x over here by adding 5x. If we go plus 5x and plus 5x, I sure hope that I haven't dropped a sign or something, because this sure seems to be working out nicer than I was expecting. Negative 4x, and of course, Tony, if I did mess up, Tony chose that moment to walk in. Negative 4x plus 5x gives me 1x equals negative 10. Before we type that in as an answer, we need to remember something. Fractions aren't always defined. Look back at the original problem. You know, when I'm looking at it right here on my paper, it looks so neat. But when I look up there in the projector, wow, this is messy. So, looking at...
This first fraction is always defined.
Because the denominator can never be 0. That denominator is always 2. What about the second denominator? What number would make that fraction undefined?
If x were another 2, would that give us a 0 in the bottom? So if we get 2 as an answer, we're going to have to mark it out. Did you get 2 as an answer?
Switch back and let's look. No, I didn't get 2. I got a negative 10. So negative 10 is an acceptable answer. Let's punch it in and see. Ah,
negative 10.
Okay. I thought I was going to get a 2, okay? I was thinking it would wind up as a 2 and we'd have to discard it, but I guess it wasn't. Okay.
Let's see about number 4.
Oh, looking at number 4, hey, they have the same denominator in both cases. What's the only number that we could get that would have to be crossed out as a solution? 2. Okay, let me write that problem down. So when y'all have those problems logging into Canvas, rest assured that it's not just a student problem, okay? So rest assured it's not just a student problem. And remember the way that
let's be more optimistic.
Okay, but remember the way I separate and I leave a lot of room, because I'm going to have to be multiplying through by something, or we're going to have to be multiplying through by something in a minute. Switch over to the paper so they can see. In the previous problem, we said that if you have distinct denominators, neither of which can be factored, the least common denominator is found just by multiplying the two things together, the two denominators together. Here, we have the same denominator. If you only have one denominator, then necessarily that has to be the least common denominator. The least common denominator has to be the only denominator that's appearing. So the least common denominator has to be x minus 2. How many times am I going to have to multiply by x minus 2? How many distinct terms do I have? 3. 1. Each fraction is a term, so 1, 2, and then that plus the 3 integer, that's a term. So we're going to multiply by x minus 2. And we have to multiply here by x minus 2 also. And I should make a note. Remember, what did y'all say was the only number that would be unacceptable for x? When do we get denominators of 0? 2. So let's make a note. I'm going to just write this off somewhere on the side. X cannot equal 2. So if at the end of this problem we get x equals 2, we got to cross it out. So, this is going to cancel nicely. The first product, what's going to cancel? The x minus 2's. That's what we wanted.
I think this one's going to work out nicer than number 3.
Yeah. X divided by 1 is just an x. The second product, what's going to cancel? The x minus 2. So we have 2 over 1, which is just
2.
There's no fraction here, so nothing's going to cancel. What are you going to do to get rid of those parentheses?
Starts with a D.
Distribute to give me plus, I'm waiting, 3x minus 6. It's not quadratic, and we need to get all the x terms on the same side. I think I'll move this 3x over to the left by doing what? Where are your red pens? Okay, I agree. Subtract 3x, so I'll go minus 3x and a minus 3x. 1x minus 3x, that gives me negative 2x. And we have a 2 minus 6, that gives me a negative 4. What do we do to get x by itself here? Divide by negative 2, I agree. To give me x equals negative 4 divided by negative 2 is a positive 2. And I start to circle this, and what do I notice? We said that x couldn't equal 2. It would give us a denominator of 0. If you tried to plug 2 into the original problem, you'd get 2 over 0 right there. No, that's a number over 0. Well, if 2 isn't the solution, then there is no solution. We didn't find another number to as a solution, so let's switch. And you'll notice...
Oh, wait. Hey, let's see, what would happen if I put a 2 in? We'll put the 2. No, it says, okay. One or more of your responses is incorrect. Nothing vague about that. Okay, well. So, option B, the solution is the empty set. I would prefer they say no solution, but instead they're saying the solution is a set of numbers, and there are no numbers in that solution. So when there's no solution, select the empty set option. Any questions there? So if there's 2 different denominators, like this one, multiply by both of them. If there's the same denominator, then those are the easier ones. On number 5,
suppose you have repeated factors in the denominator, but with one has an exponent and one doesn't. Let me write it down.
Like if you have x and x squared, or x and x cubed, or
Tony, that number 2, I miscopied the problem again, just like I did yesterday.
Once is an accident.
But
twice
a nice
seems like
carelessness. I thought 3 times was carelessness.
Oh no, 3 times is incorrect.
No, once is an accident, 2 times is misfortune, 3 times is carelessness.
Okay, well.
Okay, solve the equation.
So let me think to yourself, what am I going to have to, what can I cross cancel to get rid of both the x squared and x?
A common mistake is people just want to use x. They say, oh, the least common denominator is just x.
And that would cancel with the second fraction, wouldn't it?
But is it going to cancel this denominator, this whole thing here?
Wow.
If you have repeated factors as denominators, but with different exponents, you use the larger exponent. use x squared. I guess I'll put it over 1. Do y'all think that looks better when I put it over 1? Putting it over 1, it makes it a point. Oh, yeah. And here. I put it over 1 to make it clear that this thing can only cancel with the denominator. The thing on top can only cancel with the denominator. And this is definitely going to go cancel nicely. X squared cancels with x squared. What am I going to have as my first term? 6 minus, what's going to cancel here? Okay, x, but I'm still going to have an x left up there, aren't I? So I'll have a 40x, I agree. Equals, well, nothing's going to cancel here. There's no fraction. It's just 14 times x squared.
What do you call an equation that has an x squared in it? Starts with a q. Quadratic. So get a 0 on one side and factor, or use the quadratic formula. I always like the x squared term to be positive. So what do y'all think I'm going to do? Am I going to move the 14x squared over to the left and get a 0 on the right? Or no, I should move everything else the other way. I'm going to move the 6 and the 40x. I'm going to be getting a 0 on the left. And then I'll write it in standard form. I'll write the 14x squared first. Then is that a plus 40x? And a minus 6?
Oh, this is nice. I see something nice about these numbers that I don't think this has happened before, has it?
Not in this class. It happened yesterday.
It happened yesterday, but not in this class.
When solving these things, if you're going to factor it, isn't it easier if the numbers, especially this first number and the last number, are small? If you look all the way through here at 14, 40, and 6, could y'all think of something I could just divide straight through by 2? That'll get me smaller numbers. That's what I would do here. It'll make it easier to factor. We would have a 0 equals, is that a 7 x squared, and then a plus 40x.
Not 40.
Oh, not 40, you're right. 40 over 2, what should I write? 20x. And then finally a minus 3. Well, there's not a lot of numbers. I'm going to try to factor this. So, not a lot of numbers that multiply together to give 7. 1 times 7. Not a lot of numbers that multiply together to give 3. 1 times 3. And if you're sitting there thinking, that idiot, there's an infinite number of numbers that multiply together to give 7 and 3.
Positive integers.
I mean positive integers are just counting numbers. I'm not talking about fractions and decimals. So, well, let me go ahead and draw my 2 parentheses. What do we know about the signs? The second sign is negative, so 1 plus and 1 minus. Well, it's just a matter of thinking of how to arrange the 1 and the 3. Do I put the 3 here, or should I put it here? X plus 3, I think I agree with that.
Show the outer.
I am. We'd have a 21x and a minus 1x. That is certainly giving me that positive 20x. 21 minus 1. So we've factored it. And now set each factor equal to 0. And we get x equals negative 3. And the other ones, little bit more involved. 7x minus 1 equals 0. How do I solve that for x? Add the 1, So we have 7x equals 1. And then divide to 1 over 7. I guess we should go back to that idea of you can't have a 0 in the denominator of a fraction. Unfortunately, my copy is too messy, so look at the original. What's the only number you can square to get 0?
What's the only number you can plug in right there for x to give you 0? It should be obvious.
It's so obvious it seems like a hard question. 0.
Did we get 0 as an answer? 0 is the only number that would be unacceptable. So negative 3, that's okay. Positive 1/7, that's okay. So we come over here, we're going to punch in negative 3, and we'll punch in 1/7. And before we go on, I want to point out something to you. They're not telling you how to solve these quadratic equations. Right here, at this point, some people just say, oh, they hate factoring. Factoring is something you can, if you practice it enough, you can get good at it, okay? So, factoring, that's something that, with enough practice, you can get good at it and you can get fast at it. But suppose you didn't see the factorization. What's the other way you could have solved that equation?
And it always works.
It always works. It's not like factoring. You're sitting there and you never can get it factored.
It starts with, there's two words.
Two words.
It's what, first word starts with a Q. The second word starts with a F.
You were doing it in your last homework assignment.
Quadratic formula?
You could have used the quadratic formula for this. You know, I'm going to use the quadratic formula. We were doing one, not right now, but Tony was. There was one yesterday. If you watched the video, there was one for Tony. He saw it. Okay, and this is a factor, blah blah. As I was standing up here thinking, no student's going to try to factor that messy thing. So then I've reworked it using the quadratic formula. So when we run into one that's really messy factoring today, I'll stop myself from factoring and we'll use the quadratic formula instead. Just to remind you.
Do one more of these fractions.
Oh, you go right on ahead. Yeah, you love that.
Well, this one, number 6, is different in that it's just one fraction on the left equals one fraction on the right. If you look at the ones we've done up to this point, here we have two fractions equals a number. It's not fraction equals fraction. Here we have fraction equals fraction plus a number. If that plus 3 weren't here, then we'd have fraction equals fraction. Here we had two fractions equal no fraction. But if you just have one fraction on the left and one on the right, like problem 6, what I'm going to do is, let me write it down. This is problem 6.
One fraction equals one fraction is called a proportion. And there's a way to solve proportions. Who remembers what it's called? You take this, look at the little thing I'm doing. You're going to multiply like that and that.
So you're trying to get them to figure out
the name of what we're going to do.
Oh, wow.
That's not very good. This pen here,
Yeah,
I thought it wasn't showing very well.
It isn't showing great, but I'll see it. Oh, not only does it not show great, it looks sort of blurry to me. Should I recopy that or just go on? Oh, okay. For this, I'm just going to cross multiply.
Y'all remember cross multiply?
If you have fraction equals fraction, like right here. When I cross multiply, I'm going to have to distribute. So I'm making a note. Cross multiply. X times x is x squared. X times a minus 3 would just be the minus 3x. then equals, do the same thing over here. I'll do it in red. If I'm multiplying 4 and 2x minus 7, you got to distribute the 4. So it's going to be a 8x and a minus 28. There's no specific order. I mean, you could have done the red cross multiply first. So you have 8x minus 28 equals x squared minus 3x. We're going to see so many just fraction equal fractions that pop up throughout the semester that I think it's easier to do this than to say, okay, let's multiply both sides by what, a 4x?
I was going to ask him, what would the least, notice
Two
different denominators, neither of which can be factored, so the least common denominator would be the product, 4x, like we saw on number 3. So if you multiply both sides by 4x, you'll still get the same answer. Let's continue on.
Any questions on how I got this x squared minus 3x? It's x times x times a negative 3.
Here, I'll write it out, okay? You see, you take, give me a blank. It's x times x minus 3. Here's the little step that we're skipping. Equals the 4 times 2x minus 7. But I don't know what's going on with that light.
I'm going to turn that light off. Maybe it'd be better without.
Well, I thought you were doing this.
Go ahead, do that. Finish it up.
Oh, okay. Well, it's quadratic, so we better get it set equal to 0. Where do you think I'm going to get the 0? On the left or on the right? I think I'm going to get it on the right because I don't want to take this x squared and move it over, because if I did, that positive 1x squared would become a negative, and I don't want a negative in front of my x squared. So I'm going to get the 0 on the right. I'll subtract 8x. And I'll do what with this? Add the 28 to give me x squared negative 3x minus 8x. That's going to give me, maybe I better write it out. So that's going to become a minus 8x and a, no, okay, you're right. But I'm going to move that, and it's going to become a plus 28 equals 0. And then I agree, negative 3x minus 8x, that gives me a negative 11x plus 28 equals 0. And I'll write my parentheses. Here's something you might want to remember. If they don't tell you to solve the problem using the quadratic formula, then it is highly likely that it is factorable. If you're wondering, I wonder if this thing's factorable. Now, if they say in the instructions specifically use the quadratic formula, it's probably not factorable. They're trying to help you out there with the programmers in my lab. But as it is, if it says that it's, there were no instructions saying that you have to use the quadratic formula, so it's probably factorable. Oh, there's several nice things here. The last sign's a plus, so what does that say? Okay, so the last sign's a plus. You're going to have two of those first signs. I'm going to just put them in right now. Hey, x squared. I think there's only one possibility for 1x squared. 1x times 1x, I agree. Now 28, I keep forgetting to leave room underneath there. So here we are. 1 times 28, or 2 times 14.
I think most people will figure out
4 times 7.
Without actually writing out those numbers.
And remember,
to 4 and 7.
Remember, this is a simple trinomial, so you choose the pair that adds to give you a 11. So, I agree, 4 and 7. Y'all agree there, or do you want me to do the inner and outer to check it? Okay. Y'all agree that's going to give me a negative 4x minus 7x gives me a negative 11x? Y'all agreeing? Yes? Okay, so x minus 4 equals 0. X minus 7 equals 0. So x equals here 4. X minus 7 equals 0 means x equals here 7. That denominator here can never be 0. It's always going to be a 4. What would make this number, this denominator, a 0? It should be obvious. 0, we didn't get a 0, so both of these answers are acceptable. Okay.
Oh, both of those answers. What were they?
4 and 7.
4 comma
no.
Ooh, let's see. 4 comma 7. Or 7 comma 4. Any questions there?
Okay. The name of this homework assignment is Rational and Radical Equations. Rational equations are equations that contain fractions. Radical equations are equations that contain radical symbols, square roots, cube roots. They're not equations that are bizarre or violent. They're not that kind of a radical. They're just equations that contain radicals, square roots and cube roots primarily. And I want you to recall something from the very first day of the semester. One of Tony's little rules that he wrote on the first day of the semester. The square root of anything times the square root of anything gives you just anything. So multiplying 2 square roots by themselves, the square roots disappear, and we can rewrite it in terms of an exponent. The square root of a, quantity squared, the square and square roots cancel each other out, leaving us just the thing under the radical. And in general, okay, so first of all I'm going to write radical equations. And remember, those are equations that contain radicals, not bizarre or violent equations, not that kind of...
And by radicals, you mean square
roots and cube roots.
We haven't done anything with cube roots yet.
Square roots, cube roots. Do we have any fourth roots? I don't know if we do, but I don't recall them. But anyway, so but just equations that have radical symbols. And we said that the square root of a, quantity squared, reduces to a. Now, oh yes, I'll show that cancel out. The square and that radical are canceling themselves out. Now, the nth root, whether it's a cubed root or a fourth root, in general, the nth root of a, whatever, if it's an nth root, if there's no low number there, no low index, you assume it's a square. That's what we're used to. But for the nth root, say a cube root, you'd have to raise that to the nth power to cancel itself out and still leave us with that a there under the radical.
I'm going to write out a little strategy for how to solve these radical equations. And first I'm going to, number 9 is such a good example.
To solve a radical equation.
See, here's a radical equation right here with the square root symbol. That's what we mean by radical equation.
First of all, write out
number 10, there's one with a square root. But let me write out my strategy on how I would go about this. To solve a radical equation, first of all, isolate the radical term.
Now, if there's more than one radical term, you isolate a radical term. You've got to have a radical by itself. Now, if there's 2 radicals and you're isolating both of them, you may be isolating them both at the same time, which is really nice.
To oscillate, first of all, oscillate the radical term. Ooh, is that purple going to show? Raise both sides of the equation to the same power as the root. If it's a square root, square it. If it's a cube root, cube it.
People don't like cube roots, but I tell you, they are so much nicer than square roots. Cube roots don't produce imaginary numbers, so don't be worried about the cube roots. I assure you the square root equations are much messier than the cube root equations.
That's right. Now, second step, raise both sides of the equation to the same power as the root in order to cancel out a radical. And you'll see what I mean as we're going through this. Like all of my little sentences, they only make sense once you know how to do it. Step 3, solve the resulting equation after you've canceled out a radical. And then step 4, I'll let my brother justify why this happens. But if you have an even root, primarily a square root, not a cube root, you must check your answers. When you start squaring both sides of an equation, you run the risk of picking up numbers that aren't really solutions. You're going to get some extra solutions. So for
extra wrong
solutions. So for even roots, mainly square roots, if there is a fourth root in the assignment, that is not one you really need to check. You need to check these square roots, and I'll show you how to do that. It's going to be a little messy. Tim, do you want to talk a little bit about why?
I do.
I think for square roots, you've got to check your answers.
Okay, let's see. I claim that squaring stuff causes all sorts of problems because when you square a negative, what does it become? A positive. Now, if you're raising a negative to an odd power, say a cube, negative times negative times negative, that stays negative. So the signs aren't changing. The problem begins when you're raising negatives to even powers. Let's see, I claim that this following statement, negative 3 squared is equal to positive 3 squared, as long as we have those even exponents. Do you agree? That's a true statement. Negative 3 times negative 3 is positive 9. 3 times 3 is positive 9. So as long as you have that square there, it's a true statement. Suppose you drop.
Suppose you don't have the square.
Let's go back without. Is that a true statement? No, it isn't. So you can start off with something that's not true, but when you square it, and remember, we're going to be squaring both sides, so we're going to be running into the possibility of taking something that's negative, squaring it and making it positive to get what we think is a true statement when it isn't. It's those even exponents that mess up things. They're the things that require checking. When we get to the cube root equations in a little bit, you'll be raising both sides to the power 3. 3 is an odd number. It's those powers that are even that are going to require that checking. And to illustrate, okay, so we're going to do number 9.
And let me tell you, they don't get much messier than this one, okay, this semester.
We're not talking about just today. For the entire semester, the problems don't get that much messier than this one right here. So, the square root of 7x plus 8. Yesterday, that's one of the things that some teachers don't like. They want to do the same examples over and over. They want to know when they see that problem, and when they go into that class, oh, here are the problems, I've got to know how to do it, I can factor it easily. It's not going to be something that stumps me, but I'll tell you right now, sometimes
this is going to get some pretty big numbers.
Mm-hmm. This looks worse than yesterday's.
Yes,
Okay.
Okay, my little
Here's a little sequence of steps. The first thing we do is isolate a radical term. So we got to get the radical by itself. Well, looking at this, there's only one radical. We need it by itself, so we need to get rid of that minus 3. What do you think I'm going to do? Add 3. Okay. And that gives me, on the left side, we have the square root of 7x plus 8. And on the right side, I have a 3x. Negative 19 plus 3 gives me a... Okay. Now, my brother always likes to check the equation in the original problem. When it's time to check there at the end, I use the isolated form. Before you start squaring it, I like this form right here. I think it's easier. There are fewer terms than in the original. So this is where I'm going to check it.
And I'm going to tell you what Dr. Robertson said years ago to her class.
Yeah, I know.
She said, you just make sure you didn't make any sort of mistake. And you're going from here to here. Okay, if this is the one you're going to use.
You know, Tony, so you can either check at this format or you can check right here, okay?
But you're getting a little ahead of me. Right?
Okay.
What's
so,
the next thing I said to do after you isolate the square root?
Raise both sides. So
at
you're
that
going
point, you better cancel out a square root.
So we're going to square. Okay, we're going to square both sides. You know something? I better recopy this because the way I wrote that, that's going to interfere. Shoot. Okay, 3x minus 16. I'm going to square both sides. Square and square. What's about to happen on the left side? I think the left side's the easy one to reduce down. What's about to happen?
Square root and the square
are going to cancel out, leaving you what? 7x plus 8. I agree. On the right side, it's not just 3x squared and negative 16 squared. This reminds me of one of the problems in homework 2. We had something like 3 plus 7i quantity squared. 2 terms being squared. What are we going to have to do to square that 3x minus 16? Done.
One of those F words in algebra, 4 letters.
You're going to have to write it twice in FOIL. You don't just take 3x times 3x and negative 16 times negative 16. You have to write it twice and FOIL it out.
You begin to see why we said these get kind of messy.
First, 9x squared. 3x times 3x gives me a 9x squared. What about outer? 3x times a negative 16. I agree, negative 48x. Inner. Another negative 48x. And negative 16 times negative 16, is that a positive 196?
Oh, I thought, what am I thinking? It's 256.
256, you're right. Plus, thank you. That's a plus 256. I'm thinking 14 times 14, all right.
Mm-hmm.
Oh, goodness.
Oh, wow. What kind of equation is this? A linear or a quadratic? Quadratic. If there's an x squared, you can say quadratic. It's
I think I'm going to take an extra step, and I'm going to just combine the terms that are on the right. You have a 9x squared. Make this look a little bit better. Negative 48x minus 48x gives me a...
Negative?
No, I agree. And we still have that plus 256.
Oh, wow.
It's quadratic, which means we need a 0 on one side. Where do you think I'm going to get the 0? On the left side or on the right side? the left side. I agree, because I want that 9x squared to stay positive 9x squared. So I'm going to subtract 7x. And what am I going to do with that plus 8? I'll subtract it as well.
I have to say all these horizontal lines is different because I don't normally draw them.
The horizontal lines? I
horizontal
don't know.
line.
It just seems, I don't know. I'm in a horizontal line mood today. So we have 0 equals. We have 9x squared. Negative 96x minus 7x. Is that a negative 103x?
Oh, wow. Don't you want to factor this?
256 minus 8 gives me a plus. And I think instead of factoring, this is a good one to use the quadratic formula with. We did use the quadratic formula. We did quite a few of those problems the last time, but I don't think we had any with such big numbers, did we? I don't think so. And so this is good practice for you to use the quadratic formula. You'll see what a powerful tool it is. It's already in standard form. You have it set equal to 0. So let's try let's identify A, B, and C. A equals, B equals, and C equals. Okay, and I'm going to go ahead and write that quadratic formula out the way we were doing the last time. Negative B plus or minus the square root of B squared minus 4AC all over 2A. Hold on.
So you want to put the light back on?
Yeah. So,
Are y'all caught up with us at this point? We
Yeah.
gave you fair warning at the beginning that this is some messy manipulation.
I gave them fair warning at the end of class the last time, and look at how few people are here today.
See,
I
you
ain't giving no
scared 'em
fair
in time.
warning anymore.
Uh-huh.
No more fair warning. Everything's going to be easier. From now on, next time's easier. Okay, so here goes.
Negative B.
The opposite of negative 103 is positive 103. Oh my goodness.
Oh, you see why I got my calculator.
B squared, 103, negative 103 times negative 103 is going to be a positive.
I'm just saying, 103 times 103. Don't get too scared yet.
10,609
You might be thinking, oh wow, it'd be better to do some factoring. No.
minus 4 times A times C. I thought that problem the last time was messy, Tony.
I know, this one is metric.
Wow. All over 2 times A. 2 times 9. I can do that in my head. What am I going to have for my denominator? 18.
Now before you start panicking too much, let's simplify under that square root.
So we have 10,609 minus
And those parentheses are just times. So minus 4
4 times 9
times 248, 1,681.
Okay.
Oh,
1681 all over 18.
you might be thinking, oh wow, this looks pretty bad, but just bear with us. Lift up some.
Oh, I gotta move it up.
Let's see. Do y'all think 1,681 is a perfect square? Let me see. What's the square
Could we be
root?
that lucky?
The square root of 1,681. Y'all think it's
Is
going to be a whole number or a decimal?
nope. It's a
41.
whole number. If it's factorable, if the polynomial is factorable, when you use the quadratic formula, you're going to get a perfect square. And I'd said, I believe this thing is factorable. The instructions didn't say use the quadratic formula. And if they don't tell you that specifically, it seems like the pattern the programmers use is if they don't tell you use the quadratic formula, then the thing is factorable. And yes, it would be factorable. So we have a 103 plus or minus 41 all over 18. But you can't leave it like that.
Now, normally, if there were a square root in this, you would stop and leave the square root, but we no longer have a square root.
So let's separate. We have 103 plus 41 over 18. So here's one possibility. We're going to do the plus one. 103 plus 41 all over 18. That's a 144 divided by 18. I don't suppose 144 goes in, 18 goes in evenly, does it?
144 divided by 18.
70, I think it's 8.
Yeah, it is 8.
My mental arithmetic hasn't completely left me during the 2 years of the pandemic.
No.
Now, what about 103? We have the second option, 103 minus 41.
Well, he's writing that. Do y'all see what he's doing? The way he's breaking up the plus and the minus? The 103 plus 41 and the 103 minus 41? You might say, well, why didn't we do that on with the quadratic formula problems the other day? We didn't have any like this where
the perfect square under the radical. If there's if the number under the radical is a perfect square, then you can reduce the answer to rational numbers. And so, let's see, is that a 64?
No.
No, it isn't. It is a
62.
Yeah, 62. Okay.
103 minus 41. My mental math is going. Yeah, 62 over 18.
And let's see, it's definitely divisible by 2. That would be a 32 over 9. We could cancel a 2 above and below. I'm getting 32 over 9 for my second answer.
If I take the 62 over 18 on this calculator, I get a decimal number. If I hit math, that first thing says arrow fraction. That's convert to fraction. Now I go enter, it'll convert it as a 31 over 9.
31?
31.
Yeah, you're right. Well, look at that. 62, I was just saying my mental arithmetic wasn't that bad anymore. And was still intact. 62 divided by 2, what did I get? 32, it should have been a 31.
That's why I did that on the calculator, so you could spot your mistake.
Oh, you didn't spot it, Tony. Did you?
No.
No.
Oh, wait, we're not finished.
Now, I'm going to let you do it. You get to do the checking, Tony.
If you have an even root, square roots in particular, you've got to check your answer. And my brother wrote so large that I don't have room to check on this page. I'm going to have to move over here.
Wait, let's go back. Now, which one are you going to use to check? You can use the original, or you can use the form where the radical has been isolated.
I'll use the one that you say to use, the one where it's isolated. That means I'm going to have to plug an 8 in for both of these x's and see if we get the same answer on both sides. That'll be pretty easy, especially with a calculator. But plugging in the 31 over 9, now that's going to be a little messy. You'll definitely want a calculator for that.
But I can already tell 31 over 9 isn't going to work.
Yeah, we'll see. Okay, I'm going to say check.
Move the paper down. Okay. I'm reminded of the student that said, he just plugged them both in to see if they checked, and if not, then he narrowed it down. Okay, remove one of them. But you can't do that on a test. On a test, you don't get 3 shots to enter in the correct answer. So what we're doing is trying to be ready for that test. You'll have to check.
And I'm going to plug into the square root of 7x plus 8 equals
3x minus 16.
3x minus 16. So that's what I'm going to be plugging into. Okay. Now, when I say check, I mean plug the number in for x and see if you get the same thing on both sides of the equation. So,
working under that radical, 7 times 8, we can do that in our head. That's 56.
I plug it.
Plus 8.
So on this left-hand side, 7 times 8 is 56, plus 8 is 64. Tim, just for illustration purposes, why don't you stick that into the calculator?
7 times 8 plus 8. Sure enough, that's 64.
So we have a square root of 64, which we know is 8 on the left. Are we getting the same thing on the right? If I plug an 8 in there, yeah.
24 minus 16.
3 times 8, 24. Minus 16, 8. So we know for a fact that the answer is not no solution. The number 8 checks.
Put a big check mark there.
Oh yeah. Okay, I was going to circle.
8 checks.
Oh gosh.
Plug in the 30. I'll do the right side. Okay. Y'all caught up? I'm writing it out. The square root of 7 times 31 ninths plus 8, will that equal 3 times 31 over 9 minus 16? Don't worry about the right-hand side for the time being. I mean the left side. Look at the right side. Let's punch that right side into the calculator.
I'll punch it in exactly as you've written it with parentheses. 3 parentheses 31 over 9 close parentheses minus 16, and look what we get there.
It's negative.
Negative 5.66.
That's why I like this isolated form here, because I'm not even going to evaluate the right side. I don't see a sign in front of this radical, which means it has to have what sign? If there's no sign, you assume what? Positive?
Just like right here, square root 64. There wasn't a sign in front of it, but you assume it's positive.
This radical, that's positive. Can a positive number equal a negative number? No, it cannot. So I don't even have to go through all the, as soon as I saw the right side was going to be negative, this sign here had to be positive. It cannot check. Or you could go through and punch it in yourself and verify that it's not going to check.
Just to show them how to punch something that messy in.
With the radical, good thinking.
Square root of 7 parentheses 31 over 9 close parentheses
plus 8.
Okay. Oh, look at that. It's a positive, whereas up here you got a negative. That's sort of like what you were doing earlier. The negative 3 equals positive 3.
You see what happened when it was squared? They were both positive, so it worked. That's why we got that 31 ninths. But without the squaring, one's positive, one's negative, it doesn't work. The only number that works is positive 8.
I have to say, this is some of the messiest stuff we'll do this semester.
Positive 8.
Oh, positive 8. This is the only answer. Gosh, I hate to do this, but I'll say it anyway. Any questions on that?
So when it has a radical time, you're going to use the quadratic formula, right?
No, only if the numbers get really big. Like the next one, I don't think we'll need to.
I think the next one, the number's going to be small. I think it may even just be a simple trinomial, x squared minus something or another. That's real easy to factor, okay?
So what I do to determine am I going to use quadratic formula or factor, are the numbers big? Okay, like what was that last number? 248. I didn't want to start 1, 248, 2, 124, 3, okay? And also, we did want to show you a
quadratic
formula problem where there is a perfect square under that square root,
and how you go
and how it simplifies so nicely. Okay? Let's, before all of you panic too much, number 9 was the worst. Number 10.
Okay.
You want me to do it?
You do.
Okay. Let me write it down. Number 10. The square root of 6x minus x plus 12 equals 0. Okay. Oh, let's always try to leave it like this so I can flip back my little sequence of steps. Isolate the radical term and then square both sides. Okay. Well, what am I going to do to get that square root symbol by itself? I'm thinking it's plus the x, right? Add x. But you're right, the x and
minus the 12. Okay.
So we're going to have it written like this. Square root of 6x equals, that's just going to be an x minus 12. So very much like what we did on the first one, number 9.
Isolate the radical. Now what power are we going to have to put outside both sides? Okay, that's a square root, so we're going to square. We're going to put a power of 2 out there, which means that that number's even. At the end, we're going to have to do what? Check our answers. I think I like checking the answers on the rational equations better, because there all you got to do is just make sure you don't get a denominator of 0. Here you have to manually plug in.
Nope. So on the left, I'm canceling the square and the square root. I just have a 6x. On the right-hand side, I don't just square the x and square the 12. What's that 4-letter word that starts with F that I'm left to do? FOIL? So it would be x squared. Then we have minus 12x and minus 12x. Yesterday, a student asked, did they have to write it out twice? Well, he asked me that after class, like that. Or could he just go straight to minus 24x? And I was like, yeah, of course you could go straight to minus 24x. You don't have to do as many steps as I'm doing.
Last, 144, negative 12 times negative 12. Where do you think Tony's going to get that 0? On the left side or the right side? Yeah. Good. He's going to combine the negative 12x minus 12x first.
And
then where do you say he's going to get that 0?
Left-hand side. That's right. So we have a 0 equals x squared. Is that a minus 30x? And a plus 144?
Okay, 144 was 12.
You might be tempted to say, oh, I'm going to use quadratic formula because the numbers are sort of large. That's not 144. That's up to you, but I think I'm going to do this one by factoring.
24 times 6.
Oh, Tim, we were going to try to figure that out together. Since it's just an x squared, we'll put x and x. That's one thing that makes this one easier than over here. What did we have, a 9x squared? So,
it was the 248,
yeah.
Really.
And for 144, I think in numbers, 144 times 1, 2 times 72. What's 144 divided by 3?
Yeah, 144 divided by 3 is 48.
144 divided by 4, is that 36? 5 doesn't go into it. What about 6?
144 divided by 6, I think it says 24, doesn't it?
Uh-huh. So,
7, 8.
oh yeah, 8 divides evenly into it. Is it 8 times
18?
And, oh wait, there's still another pair. 9.
times
12 times 12. You see, it is still a pretty large number, so there's a lot of possibilities.
9 times 16.
Oh, I didn't write 9 times 16. Oh, darn. But you'd already said that the pair that works. Which one will add together to give that middle term? Since the second sign is plus, we have 2 of the first. And 6 and 24 work. Oh, heck, it's even going to be easy to check. Why am I saying that?
Because the possible answers are integers.
Yeah, no fractions. And if I remember to, I keep thinking I'm going to do it. I'm going to look and make sure that I'm going to try to make sure that your test doesn't have ones where you have the fractions to check. But I can't guarantee it. I'm going to try that. I'm going to try. Okay, Tim? Okay.
What are the 2 possible? You haven't finished the
I know.
problem.
So I set each one of these to 0. And we get x equals 6. And what's the other one? 24. Isolate the x by moving the 24.
And this one in particular, I think it's easier to check it where it's been isolated.
Yeah.
So the square root of 6x is equal to x minus 12.
So this is where I'm checking. Square root of 6x equals x minus 12.
Do not check once you've squared it. Because once you've squared it, once those square roots, the even exponents have been added, of course it's going to work. You're having to check the thing that has the radical still appearing.
So I'm plugging it in here before I squared it. The square root of 6x equals x minus 12. When I check it, I plug in the x. So let's see, on the left-hand side, what would we have? It'd be a 6 times 6. Is that a 36 under the square root symbol? So in other words, we have a 6 on the left. What are we going to have on the right? If I plug a 6 in for x, I'm getting a negative 6.
So somewhere along the way, once we squared all that stuff, some negative became positive. That's why we got that answer that we're going to have to cross out. 6 does not work. Those answers that have to be crossed out are called extraneous solutions. I bet you 24 works. I'll tell you right now that if you're solving a square root equation and you have 2 possible solutions and one of them doesn't work, odds favor. If this were a game in Vegas, I'd go there and they'd give me the 2 solutions and tell me this one doesn't work. What do you think is going to happen with the other solution? I'd bet every time it's going to work, and I'd walk away winning a lot of money. Of course, they're not going to ever make a game like that.
What would we have under the square root if I plugged that 24 in here? Okay, 6 times 24 is 144. And we know the square root of 144 is 12. What about plugging the 24 on the right-hand side? Are we going to get the same thing? 24 minus 12 is 12. Those are equal. Check. So I'm saying that, which number are we going to say is the solution? 24?
24 checks. 6 does not.
If you didn't like doing factoring on that one, it works out cleaner than this. This one using the quadratic formula. And that's up to you, how you want to go about solving it. So general rule of thumb, if the numbers are real large, I use the quadratic formula. And here 144 isn't that large. It's especially since there wasn't a number in front of the x squared. So the answer was 24.
Any questions there?
Oh, we didn't take our break, but we have the next one. It's about to get less involved.
Because we're moving to cube roots. And cube root equations, you have to cube both sides.
But you don't got to check them. So,
Because once again, cubing doesn't change signs. You take a negative number and cube it, it's going to stay negative. Negative times negative times negative stays negative. Hopefully the way we check those last two answers, you see the problem is the way you wind up taking negatives and they become positives when you square. So, like this one here, number 11.
cube root of 3x plus 9, and then a plus 5 equals 2.
Instead of squaring both sides, we're going to have to do what?
Cube.
But before you start cubing, what are you going to have to do?
What is my little...
What's that little Tony's little recipe? First, you have to
isolate the radical term. Don't start cubing until you move, or until I do what? How am I going to get this cube root by itself? Yeah, minus the 5. Good. So I'd have the cube root of 3x plus 9 equals 2 minus 5. Am I going to have a negative 3 on the left?
Mm-hmm. If that were a square root, I'd just say no equation and stop. No solution, because that sign there is positive. But with a cube root, you can have a negative number under there.
So you just basically said that cube roots are easier, but you said if this were square root, then you would be finished.
Yeah, but nobody else would spot it except someone that's been doing this stuff for 32 years.
Okay.
So you cube both sides.
And the cube root on the left cancel out, leaving just 3x plus 9. Now be careful. Do not say... Don't say negative 9. What's negative 3 times negative 3 times negative 3? Negative 27. Negative 3 times negative 3 is positive 9, times another negative 3 is negative 27.
You're not even going to have to factor this. You use the quadratic formula. It's linear. So what will we do to solve this? There's only one sensible next step. Minus the 9. I agree.
So we have 3x equals, is that a negative 36? Negative 27 plus negative 9, negative 36.
And then we will divide by
3. And we get x equals positive or negative? Yeah, negative 12. Do I need to check or do anything? No. This course just doesn't keep getting harder and harder and harder and harder.
Make a note. That little number right there, the way you raised it to an odd power, it's odd. So don't check. You can check if you want to. It's just not necessary. Okay? That's when you raise both sides to an even power that you have to check. The old Hausler-Paul finite mathematics book that we were using the first year that we taught here at Del Mar in 1990. I remember we were discussing radical equations, and the book had this, this big box, and it was marked important. Raising both sides of an equation to an even power does not guarantee equivalence, but raising both sides of an equation to an odd power guarantees equivalence. And I was like, oh, that's such a brilliant statement. Students didn't appreciate it, but
type in the number. We only have 2 more to go, Tim, so they're ready to get out of here.
I tell you.
So what is that solution? A negative 12? What else? Oh, number 14 is no. Wait, let's see. What's the next one we're doing? No, 12 and then 14.
Oh, I'll do 14. Okay. From the top.
Okay.
I'll let you do number 12.
Oh, number 12. Cube root of 6x squared plus 6x minus 5, then a minus cube root of 7x equals 0. You can impress people with these if they don't know much math. Algebra. It looks pretty messy.
First step, when solving a radical equation, you must isolate a radical. There's two of them. Which one do you think would be better to move? This first one or the second one?
Yeah.
The second, that's the smart thing to do because you're getting rid of that minus there in front of it. So in that case, when you isolate one radical, you're also isolating the other one at the same time.
So I'm writing it like this, and then cube both sides. It's going to look like all I'm doing is just dropping the radical, doesn't it? Because the cube and the cube root cancel. And we have a quadratic equation. 6x squared plus 6x minus 5 equals 7x.
We need to get that set equal to 0. Where do you think he's going to get the 0? On the left side or on the right side? The right side, because he already has a positive coefficient on that x squared, so he doesn't want to move that.
So it's going to be a 6x squared. Is that going to be a minus x and a minus 5?
Yes.
Equals 0.
What do y'all want to do? Factor or use the quadratic formula? We're going to let y'all decide. Factor, okay. Now for 6, there's 1 times 6 and 2 times 3. But 5 is pretty nice. Only 1 times 5.
I went ahead and put in the 1 and 5.
Hey, the last sign's a minus. What do we know about the signs inside the parentheses?
The second sign is
sign's a
minus.
You have 1 plus and 1 minus.
Normally I'd try the 2x and 3x, but I've noticed something. I want these numbers to the outer and inner to subtract to give the middle term. And what I notice is that if I subtract 6 and 5, I could get a 1. I'm thinking it's going to be the 1 and 6 that I need to use. The 1x and 6x.
Notice if you put the 6x here, when you did the outer product, 6x times 5, you're getting 30. You're pulling way far away from the minus 1x that you need. So,
am I right? Is this going to give me a negative 1x? How would I need to arrange the plus and the minus signs? Minus here, that would give a negative 6. Then plus 5 would give the negative 1. This one's a little bit more involved than number 11, but it's sure not like number 9, is it? All I have to do now is set each factor to 0 to get x equals 1.
And here's what. Is it going to be a negative 5 over 6? Are y'all caught up with me? You don't need to check it. It's a cube root, not a square root. So positive 1 and negative 5 over 6. Any questions before we type in those answers? Okay. I'm going to type them in. I know some of it at this point we're probably just, what we're saying is just hitting you in the face and bouncing off. But we got to keep going. There's another one we need to do.
Now, one more. Number
One
14
more.
is just do this.
Number 14, and I'll do this one.
Mm-hmm.
Oh, goodness.
Number 14 looks.
I don't even see any radicals. What is that? Look at those exponents. Blow that up, Tony. Look at that, those exponents. What have we got there? Have we seen those before?
There's no radical. There's no square root or cube root, but there's these bizarre fractional exponents. Tim, review for the class what a fractional exponent means.
A fractional exponent is nothing more than another way of expressing a radical. In general, fractional exponent. A to the 1/2 is the same thing as the square root of A. Once we get to logarithms, we'll have to be converting the square roots to fractional exponents of 1/2. So this is something that's going to pop back up, and it's going to be important. In general, suppose that little denominator is not a 2. A to the 1 over n is the same thing as the nth root of A. So that problem that we had written up, that flashed up there on the screen a moment ago when it had an exponent of 1/3. An exponent of 1/3 would be what type of radical? A cube root. Okay. So these fractional exponents are nothing more than just other ways of expressing radicals. Oh, what have we
I
got
found a
there?
sheet of worked out some problems with the class in the spring 2020 playlist. This was like January, early February 2020, and I'd written out a square root, square cancels, cube root, cube, and so forth. Then I wrote out my little steps that I've already given y'all, and then I wrote all of this out. A 1/2 exponent is a square root, a 1/3 exponent a cube root. Finally, a 1 over n exponent is an nth root. Okay, so is number 14 a hard problem?
Not if you realize that 1/3 those 1/3 exponents are just cube roots. Let me write it down. We have the binomial 3x plus 6 raised to the 1/3 power minus the binomial 6x minus 1 raised to the 1/3 is equal to 0. Well, that's nice at least. There. Okay. First thing I'm going to do, I'm rewriting the 1/3 exponent is the same thing as a cube root. So we have the cube root of 3x plus 6. This is going to look a lot better once we do this. Minus the cube, if not better, it'll look more familiar. The cube root of 6x minus 1.
The most basic problem-solving strategy is if you know how to do one problem when confronted with another one, a new type of problem, make it look like the one you know how to do. You know how to do number 12, where it was cube root minus cube root equals 0.
So what do y'all think I'm going to do? Not yet. isolate. I'll isolate it first. Oh, and I'm going to move the one that has the minus in front. I'm going to move that over because so that minus will become a positive. Okay. So we have a cube root of 3x plus 6 is equal to the cube root of 6x minus 1. And then we're cubing both sides. Look how nice this is going to be. And what happens with the cube and the cube root? Cancel out, okay. To give me just a 3x plus 6 equals, y'all tell me what we have over here on the right. Okay, the 6x minus 1. And
linear or quadratic? What do we have here? Starts with the L.
Linear, there's no x squared. So what do y'all think we need to do?
Isolate the x.
I'm going to let y'all tell me what to do. We've got to isolate the x term on one side and get
let's do it so that we get as few negatives as possible. How would y'all move the stuff? One side's going to...
Okay, I agree. We'll move that 1 over, plus 1 and plus 1, and then we'll minus the 3x. Okay. Okay, that's a good approach, Tony. Minimize the number of negatives. Research has shown that students have a tendency to mess up. The more negatives in a problem, more students mess up. The 3x minus 3x is gone. What have we got here on the right? On the left side.
6 plus 1. They know it's 7. They don't have to say that.
Oh, and what about here on the right side? I'm waiting. 6x minus 3x is 3x. Divide by 3 to give us x equals 7 over 3. And do I need to check my answers? No, because the exponent we used was
odd.
An odd number, a cube. So 7 over 3. We're going to be, oh goodness.
7 over 3. Oh, let me make it a little smaller so I can type in 7 over 3. Okay.
The next assignment will be less rigorous. Oh, look at that.
Just starting at this point, trying to find 15 problems for every assignment can be difficult. Starting with this one, in order to get 15 problems, I'll be sticking on a few review problems, like just solve using the quadratic formula. So number 15, is it anything new? It's what we've done before. But starting at this point, our homework assignments, if I can't find 15 problems,
that you want to assign.
Yeah, that I want to assign, I'll stick on review problems for y'all. Most assignments had 15 problems. There's one or two, like the first one, that square root assignment, did it at 15.
It had more.
It had 20, okay? But there's even a few problems that I gave up, assignments that I gave up at 12, okay? So that is it.
Any questions? Okay.
Let me see. Oh yeah, I'm going to stop my recording. Wow, 3 weeks down. Only 13 more to go. Doesn't seem that impossible anymore, does it?